has gone wrong. That is why I said write it down 3 times. Valency, symbol, formula. If that is more important, keep looking there. I'm going home and I'll start my night rest. Have I made myself clear to you? Look at me and me alone. Foolish fool. Now, so you got calcium. If you don't know this, it will be a 0. Right here you get a 0. Correct? Now, only the balancing. Only the balancing. That is this. That is this. Only the balancing. Only the balancing. Only that you bring down here. This you take here without the sign. Only the balancing, not the sign. So therefore, it is 1 and this is 2. Followed. Now write down the formula. Ca1, Cl2. Ca1, Cl2. Now we don't write this one. So it becomes CaCl2. But this working has to be there. This working, do not change it, do not rub it off. Is this clear? So if there are 2 marks, you have got here half, 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 half. 2 marks. You don't write down this, half a mark, cut 1.5 mark. And I don't round up. I don't round. I cut off 1.5 mark will be 1 mark. Miss, but I got 1.5. It should be 2. Who told you 1.5 is 2? Whoever told you 1.5 is 2? 1.5 is 1.5. In my case, 1.5 is 1. I cut that half also. Suppose you have got sodium carbonate. Suppose sodium carbonate. Sodium carbonate. What is the formula for, what is the symbol for sodium? Na. What is the valency? +1. We'll just put plus. We'll put 1. Don't take that sign. Carbonate, CO3. And it is 2. And it is 2. Now this 2 and this 1. This will come here. 1. This will go 2. So it is Na2, CO3, 1. Now, CO3. So this whole thing is 1. Whole thing is 1. It will make a difference here because C1, O3, 1. C multiplied by 1 is C. O3 multiplied by 1 is 3. So the formula will be then, final formula, Na2, CO3. Who have not understood this, raise your hands. All of you followed it? Suppose we have got aluminium sulfate. Suppose you have aluminium sulfate. Aluminium sulfate. Sulfate. Aluminium is Al3. Sulfate is 2. Correct? Actually, this whole thing is 2. Huh? This whole thing is 2. The whole thing is 2. So what do we do now? This will come here. 3. This will come here. It will be 2. So it will be Al2 SO4 whole bracket thrice. It will be actually what it's supposed to be is, it's supposed to be S3O12. Yes or no?
Yes.
Yes or no? Who has not understood this? Raise your hands. Didn't understand? You understood? You understood? You understood? You understood? From where I got this 3? That girl. From here. And this 12. 4 3s are 12. So therefore the final will be Al2SO4 whole bracket price. 12. Sorry, yeah, 3. So, 1 moment. Yes, 3. Aluminium sulfate. This is clear? All of you? Any more? You want me to do any more examples with you? Suppose you have got, say, for instance, copper nitrate. Suppose you have got copper nitrate. Huh? Suppose it is copper nitrate. Copper nitrate. Copper nitrate. Nitrate. Okay. So copper is what? Cu. 2. Nitrate is 3, 1. Okay. But this one will come here. This one will come here. And this 2 will go here. So you'll have CuNO3 whole bracket twice. This is copper nitrate. Cupric nitrate. And if it's cuprous nitrate, it is CuNO3. If it is cuprous nitrate, it is CuNO3. Why it's CuNO3 in cuprous nitrate? Why is cuprous nitrate CuNO3?
Because of the valency.
What valency? Whose valency?
Cross and exchange.
You are not paying attention. Cuprous. What is the valency of cuprous?
Plus.
No, cupric. The higher valency is IC, I told you. The higher valency is IC. I said cuprous. Cuprous is and nitrate is what? 1. So what will be the formula then? Correct. Or you are scratching your head. Scratch your brains. This far he's sleeping and he's scratching his eyes and he's sleeping. Followed now, all of you? So now, shall I go to how do you name compound? Now. So, now, always when you write down the name of a compound, the metal will come on the left-hand side, the non-metal comes on the right-hand side. See, metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal, metal, non-metal. Always the metal will come on the left. First the metal will come. After that will come the non-metal. That is the way you name. Okay, so that means if a compound contains a metal and a non-metal, you will name the compound using the metal first. Okay, so if a compound contains copper and nitrogen, then we would say it is copper nitride or copper nitrate or cuprous nitrate, whatever. Metal comes first, the non-metal comes afterwards. Suppose you have got 2 non-metals. Suppose you've got 2 non-metals, PCl3, non-metal, non-metal. Go to this. This is tri. This is phosphorus. Phosphorus trichloride. Phosphorus trichloride. If you've got SO2, non-metal, non-metal. Sulfur dioxide. This, you have to see this into consideration. Take P2O5. Take this, phosphorus pentoxide. These are 2 non-metals. Check this. And from here you get the name. Pentoxide. Pent. Name is there, phosphorus pentoxide. Okay? Yeah.
If the both containing the same elements, the carbon monoxide, CO2.
Then it is carbon monoxide.
If other elements.
That's it, huh?
If the other elements contain the same.
I didn't follow what
If other compounds like carbon, in case carbon monoxide get the same situation, that both have.
So suppose it says carbon.
Carbon monoxide both have the same number of atoms.
So you don't have to bother about it, anything. You don't have to bother about anything. Just plainly name it according to the symbols. Carbon. oxygen is 1, mono. If it is oxygen is 2, carbon dioxide. Okay? If it's carbon CO3, then we wouldn't say carbon trioxide. We would say carbonate. Because it's a radical. So as you go further and further, the rule will slightly change. Generally speaking, this is the one. Okay? Now, suppose you have got 2 elements, okay, and there is 1 oxygen in there, 1 oxygen. Suppose you've got, say, 2 elements of sodium, NaClO, only 1 oxygen. All right? There's a metal, there's a non-metal, there's a non-metal, but oxygen is a key factor. 1. So we will call this, when if it's 1, it's called hypo. Hypo. 1 means hypo. So what will be? Sodium hypochlorite. Sodium hypochlorite. Hypochlorite. 1 oxygen hypochlorite. Okay. That means, in other words, this 1 oxygen, 1 is less than 2. Okay. And that is the means you can't say no oxygen. It will be sodium chloride then. So if it's 1 oxygen, hypo. If it's 2 oxygen, NaClO2. The word hypo is taken out. You just write down right. It is right. Right. So be sodium chloride. Hypo cut out. If it is 3, NaClO3, it is 8. Sodium chlorate. And if it's 4 and more, perchlorate. So it is NaClO4. It will be sodium per. Per means 4 and more than 4. Perchlorate. Correct? When you are naming acids, I got this out. When you are naming acids, first of all, remember one thing, children. That acids always have to contain hydrogen. All acids contain hydrogen. I am making this statement. All acids contain hydrogen. All compounds containing hydrogen are not acids. I didn't say that. I said all acids contain hydrogen. But all compounds containing hydrogen are not acids. Correct? So now, if you have got just say 1 hydrogen and 1 element, 1 hydrogen, or you have got hydrogen and bromine, and hydrogen and chlorine, then this is, this is hydrogen. This is chloride, bromide, chloride. We will call this IC. When there are only 2, hydrogen and chlorine, then it becomes hydrochloric acid, hydrobromic acid, hydrofluoric acid. When there are only 2, okay, then the IC comes from here, bromic, fluoric, chloric, hydrochloric acid. Okay, you want me to write on the board? Hydrochloric acid, hydrobromic, because there are only 2. But it is more than H2SO4. There's a difference. There's hydrogen because it's an acid. But this is more. Then the hydrogen is taken off. And you talk about the latter part. Sulfuric acid. Then HNO3. Nitric acid. Hydrogen is out of the question now here. Hydrogen is given weightage only when there are two. But when there is more, then you have to give weightage to the second part. H3PO4, H3PO4, phosphoric acid. Phosphoric acid. Hydrogen is out of the question. If this is less than 4, if it is 3, suppose it is H2SO3 or HNO2 or H3PO3, H3PO3, phosphorus. What will it become now? It will be sulfurous, nitrous, phosphorus. Okay? When it is less than 4, OS, sulfurous, nitrous, phosphorus. But if it is 4, ik, sulfuric acid, nitric acid, phosphoric acid. Okay, read till there. Then we start with how to balance an equation. Come on, start read till there. All of you read till there, please.
And then when is bi, you said bisulfuric.
Bisulfuric acid. There's never nothing in bisulfuric. Definitely not.
Bisulfate.
Yeah.
It's like bisulfate.
There is bisulfate.
Yeah.
That is when you have two sulfate radicals. H is there. Suppose you have got. I'll tell you, wait. You've got this sodium carbonate, and you've got sodium bicarbonate. Okay, sodium bicarbonate. Now you will say bi. That means there should be 2 here. Is there any 2 here? Then why is it called bi? Why is it called bi? There are 2 different elements here also. There are 3 different elements. 3, 3, 3, 3. So many of them. It is big. Louder, can't hear. I'm deaf. Arey, Baba, I'm deaf. Hydrogen, yeah, hydrogen is there. But bi doesn't mean hydrogen is not bi. Bi means 2. Anywhere in the world. Because carbonate valency. It is 2 here also. It is 3 also here. It is because when we use this and use this, this will give you double the amount of carbon dioxide than this. Correct? This is a commercial name, a trivial name. Sodium hydrogen carbonate is the IUPAC name. Sodium bicarbonate is the trivial name, a common name. Similarly here also, sulfate. Somebody used to say sodium Na2SO4, sodium sulfate. And you have got sodium bisulfate. Bisulfate meaning it gives you double the amount of carbon dioxide, sulfur dioxide. It gives you double the quantity. Bi meaning double. It gives you double the quantity of sulfur dioxide, double the quantity of carbon dioxide. This is used in your fire extinguishers. Fire extinguishers, you need double the quantity of carbon dioxide. How does carbon dioxide put out fire? Carbon dioxide does not put out the fire.
Non-supporter.
Yeah, how does it put out the fire? What happens is when you see, you have the just look at my fingers. You have the bottle, okay? Fire extinguisher bottle. inside the bottle, 3/4 is filled with sodium bicarbonate. Okay? And above that level is a saucer, which is held by a steel rod. And the steel rod comes outside the bottle. The bottle is covered and the steel rod there is knob. That saucer contains acid. That saucer contains acid. Now what happens is when you have the fire burning, okay, you hit that knob. When you hit the knob, you have turned that saucer inside. And all the acid has fallen onto the sodium bicarbonate. And carbon dioxide has been released in that bottle. So when you press the lever out, there is a lever, you focus that foam, the carbon dioxide, on the fire. That foam covers or makes an umbrella of carbon dioxide over the fire, cutting off oxygen from the air to the fire, and that's how the fire is killed. Carbon dioxide doesn't put out the fire. Carbon dioxide cuts off it forms an umbrella. And the more the carbon dioxide is given out, the more you can put it on the fire, the thicker is the umbrella. Thick layer, preventing the atmospheric oxygen from coming in contact with the flames. And the flames die out. Follow? Double the quantity. Okay? What? Is you know this? Doesn't know about it. This is the mechanism of the fire extinguisher. So why buy? Buy means double the quantity.
It was thought but of dry ice fire.
Huh?
Of dry ice fire.
Dry ice. Dry ice is very expensive. Dry ice is a sublimate. It's difficult to get dry ice. These fire extinguishers are all hung on the corners of your room. You just pull it out and hits and start. Dry ice is very difficult to get.
I school is taught us that dry ice is inside the fire.
No. It is carbon dioxide, which is produced by the evolution of the acid thrown on top of sodium bicarbonate. Okay?
Is there any specific acid?
Loudly, no, HCl. You can use sulfuric acid, but it depends upon the commercial value of the acid. If you can do your work with cheap acid, we use cheap acid. No? Otherwise, the extinguishers are very expensive. Mostly HCl. Read. You want the book? You come and take the book. You didn't go now in the recess? Huh? Why? Go. Otherwise, you'll make a mess in the classroom only. We'll convert the classroom into a washroom. Run! Children are very dangerous. Huh?
Placing oxygen in ammonia.
Who asked you to open your mouth? Huh? Who asked you to open your mouth? Not ammonia, urea.
Ammonia we
Huh?
Chemistry periods is like that.
Finished?
Someone was there.
I told you, foolish boy. Now you don't make anything in the classroom, I'll beat you. Finish, shall I start with chemical equation or you still want to read? Huh? Chemical equation? Okay. Now, how do we write a chemical equation? How do we balance a chemical? I don't want. How do we balance a chemical equation? How do we write a chemical equation? How do we balance a chemical equation? Now, first of all, remember one thing. In a chemical equation, you have to write down the reactants on the left-hand side and the products on the right-hand side. Correct? You have to write down the reactants on the left-hand side, the products on the right-hand side. If there are two or more reactants, what you heard? Your mind is down there because you want to go to the toilet now? Huh? If there are two or more reactants, they are separated by a plus sign. So suppose you have got A, B, these are the reactants, okay? And on the left-hand side, and on the right-hand side, we have got the products. Okay? And if there are two or more products, they are separated by a plus sign, correct? The reactants and the products are separated from each other by an arrow. The head of the arrow will tell you in which direction the reaction is proceeding. If the reaction is moving in both the directions, okay, a reversible reaction, we use half-headed arrow. Half-headed arrows, the heads in the opposite direction. Half-headed arrows, correct? Above or below the arrow, we'll write down the conditions that are required for the reaction to take place. You can have, say, heat, you can have, say, pressure, you can have catalyst, yeah. Heat means you can say energy in the form of light, in the form of sound, in the form of electricity, okay, electricity, any form of energy, okay. Then if it is in a closed vessel, or in an open vessel, all conditions are put above or below the arrow. This is clear? Then also, we write down the state of the reactants and the products. If it's a solid, we write in solid. If it's a gas, gas. If it's a liquid, liquid. Similarly here, if it's a solid, if it's a liquid, we write down the short form. Similarly here also, if it's solid, if it's liquid, whatever. If a gas is there and it's liberated, we put the arrow upwards. That means gas is going upwards, being liberated. If there is a precipitate formed, it is put downwards. Heavy, correct? That's precipitate. This is precipitate. PPT, and this is gas being evolved. Then we will write down if we have given it energy, if we have given it heat energy, then it's said to be endothermic. We have added plus VE means it is endothermic. Endothermic means endo means inside. We have given it energy. Endo. And if heat is liberated, exhuming, getting out. So heat is negative, so that means it is exothermic. Thermic means therma meaning energy, heat energy. So this is how you have to write down a chemical reaction. Okay, so I will take, how to write a chemical reaction? We write down the reactants on the left-hand side and the products on the right-hand side. If there are more than one reactant, it is separated by a plus sign. If it is more than one product, they are separated by a plus sign. The reactants are separated from the products by the arrow. The head of the arrow will tell you in which direction the reaction is proceeding. If the reaction is a reversible reaction, that means it's moving forward and backward, then it is represented by two oppositely arranged half-headed arrows. Then we will write down the conditions that are used for the reaction to take place. If you get heat energy, all that is written down above or below the arrow. Heat energy or pressure or catalyst or electricity, whatever we use, whatever energy we use in whatever form. If it's a closed vessel or open vessel, that also we write down. Closed reaction, open reaction. Then the physical states of the reactants and the products are also written. If it's a gas evolved, the arrow is passing, it's moving, drawn upward. If there's a precipitate form, the arrow points downwards. If heat is supplied, energy is supplied in the form of heat, it is said to be endo, inside. We're giving the heat inside the reaction, endo. And if heat is evolved, then it is said to be exo. Heat is exo. Now, what is a catalyst? Who knows what a catalyst is? Huh?
Thank you.
It
Speeds up the
is
reaction without undergoing the
What's the meaning of that?
chemical change.
What's the meaning of that? Speeds up the reaction that are undergoing the reaction. Huh?
This catalyst is a substance that either increases or decreases the rate of the chemical reaction without reacting with the substances itself.
Without
Without undergoing anything. You said you. Okay. I'll tell you how. First of all, what is a catalyst? A catalyst is a chemical whose presence influences the rate of the reaction. Whose presence influences the rate of the reaction. Mark my words, children. Mark my words. Whose presence influences the rate of the reaction. If the reaction is going or is proceeding very slowly, then we use a catalyst to speed up that reaction. That catalyst is called a positive catalyst or an accelerator. If the reaction is moving so very fast that even before we are able to collect the products, the reaction is over, then we have to slow down that reaction. So we use a negative catalyst or a retardant. Either when it's an accelerator or a retardant, its presence has to influence the reaction without participating in the reaction. Its presence is required. How does a catalyst work without participating in the reaction? I'll tell you how. You are in my classroom and suppose you are making a big noise. Only suppose you are making a big noise in my classroom. Only suppose. It never happens. It will never happen. But only suppose you are making a lot of noise. And I'm trying to keep you quiet. I'm raising my voice and you are still making a bigger noise. And the more that I raise my voice, the more commotion is there. No learning is taking place. No reaction, no product is formed because you are just making a noise. Anubhav sir, he has seen all this in his office. And he has come and he has just opened the classroom and stood there. Immediately, you are silent. His presence has influenced the silence. Did he say, you get out, this is lower, you get out, you can't control the class? He did not say anything. He did not do anything. He just stood there. Immediately, it brought out the desired reaction. That is, you were quiet. And I was allowed to teach. And then he turned around and he went away. If you all had to jump on him, catch him, tear his t-shirt, tear his tie, and send him out of the classroom, that means he participated. But it did not happen. He just turned around and he went the way he came. That is how a catalyst works. Basically, it does participate in the reaction. He has participated. He got up from his room. He came here. He stood here. He stared at me. He stared at all of you. He did interact. But he left the way he came. So also, a catalyst does participate in the reaction. If you go to see the The mechanism of a chemical reaction. You see the mechanism step by step, step by step. If you can watch the mechanism, you will see that the catalyst has participated. But at the end of the reaction, it got regenerated. You put 10 kilos, 10 kilos came out. How do you come to know? Because in the products, the catalyst is not there. In the product, if the catalyst is magnesium dioxide, there should be some magnesium, there should be some oxygen. There's no oxygen, there's no magnesium. That means it has not participated. It has not combined. It has only influenced. That is the role of a catalyst. Now, what is the difference between liquid and a solution? Liquid, what's the difference between liquid and solution? Now, these words that are using so very, very freely. What's the meaning of liquid? What's the meaning of solution?
A liquid is a state of matter, and a solution is a solid dissolved.
Not very clear. Not very clear. Okay, I'll tell you how.
A
Suppose-
mixture of two liquids.
Suppose I give you a beaker of water and some sugar. And I give you only sugar. Give me liquid sugar, you give me liquid sugar with what I am giving you. What will you do? You will dissolve it. You dissolve. What have you done? You've taken sugar and dissolved it in water. How will you give me liquid sugar? You have melted it. You have melted it, gradually it will become liquid. Correct? And if you have forgotten of the spoon rings, that liquid become brown
Caramel.
and from there it become black. Caramel sugar, caramel is prepared, no? Okay, fine. Now, in this case, she gave me liquid sugar, but she used sugar as a solute and water as a solvent. So she gave me a solution. Basic definition, a solution must contain solute and solvent. That is a solution. And because she used water as the solvent, it is aqueous solution. If you use petroleum as your solvent, petro solution. If you use alcohol as a solution, it will be called alcohol solution. In this case, he did not use any liquid. He did not use any solvent. He just melted it. So this is said to be liquid. This is a solution. Was there any solvent here? Only solute was there. So only solute cannot be a solution. Solute and solvent is a solution. Okay? So this is what I said. If it's liquid, there is no water. There is no solvent. And if I use a solution, I will put aqueous solution. I will put that down. Here I'm using only liquid. Followed? All of you understood? Okay. Go, please, go. Long time you should have gone. I'm getting scared here. For what? Foolish boy. Take it. Come on, Hardeep, I want to tell you how to balance an equation now. How to balance an equation. Now, copper sulfate, sodium hydroxide gives you copper hydroxide and sodium sulfate. Now, if you are balancing an equation, you've got to follow the law of conservation of mass. Why do we balance an equation? We balance an equation because we have to see that that equation satisfies the law of conservation of mass. What is the law of conservation of mass? Matter can neither be created nor destroyed. It can be only converted from one form to another. So copper sulfate,
I know to balance.
Huh?
I know to balance.
keep your mouth shut, go ask you whether you know what you know. So copper sulfate got converted to copper hydroxide, sodium hydroxide got converted into sodium sulfate. Now we have to make sure that the atoms of the elements are equal on both sides. Now we've got copper here, we've got one copper here. Okay, balanced. We've got sulfur, one sulfur here, we have got one sulfur here, balanced. We've got four oxygen and one, that is five oxygen. We have got 4 oxygen, 5, 6. Okay?
Two and
Put 2 and
One. So therefore now what do we do? We have got OH. Now okay, we've got sodium here. There is 2 sodium here. There's only 1 sodium here. OH, I told you there's a problem here. H also there's a problem. There's 1 H here and there are 2 H's here. So we will have to see by trial and error method. This is the method that is there for your course. There are other methods, perhaps the teacher may show you, but that is not in your course as per your syllabus. Your syllabus is by trial and error method, meaning you use a pencil and you keep on changing it till you get the final result. Okay, so we start with now. Here, Na is 2 here, so we put here 2 Na. 2 Na. So 2 oxygen, that means 4, 5, 6 oxygen. So here we've got what now? 4, 5, 6 oxygen. Have you got it correct or not? Yes or no? Yeah. Then you have got now 2 hydrogen. 2 hydrogen, you have got 2 hydrogen. Okay? Na2, 2 Na. Sulfur is 1, sulfur is 1. Oxygen, that way balanced. Equation is balanced. Okay? Any other one you want to do? Suppose you have another one now. Take another one from here. Copper plus sulfuric acid. Okay. Take this one. Copper plus sulfuric acid. Copper plus sulfuric acid will give you copper sulfate. Copper sulfate. Plus you're getting hydrogen. Okay? Copper sulfate plus you're getting hydrogen. That is you're getting water plus you're getting sulfur dioxide. Okay. I'll give you one. Let us see whether anybody can help out. Huh? What happened? What? Now here, copper sulfate, copper. Sulfate, sulfate. Hydrogen is 2, hydrogen is 2. Okay? Now, sulfur, you've got 1 sulfur, you've got 1 sulfur. And there's only 1 sulfur here. So what do we do then? We put 2 sulfur here. There's only 1 sulfur here, but there are 2 sulfurs here. Correct? So we have to put 2 sulfurs here. So if you're putting 2 sulfur here, so that becomes 2 sulfur. So you got 1 sulfur here and 1 sulfur here for balance. You got 2 twos are 4. 4 hydrogen. And hydrogen is only 2. So what I put here? 2. 2 twos are 4. Now, if I put that means I have got what now? How much of oxygen?
8
2,
oxygen.
4, that is 2 and 2, 4 oxygen. 2 and 2, 4 oxygen. Yes or no? Pardon me, 4. And this is another 4, 8 oxygen. Have you got 8 oxygen here? You got 4 twos are 8 oxygen. Balanced. Is this clear, all of you? Now remember, you notice something that I am changing the numbers or I'm putting numbers before the compound. I am not putting the number here. I could very well put here 982. I shall put it 4 here. Did I change it here? No. Why? Why I did not interfere with this, but I put it here? Because this is quantity. Here you are changing the entire compound. Do not touch here. You can change here. As many times you want to rub out, you can rub out. Change before, not inside the compound. Because changing inside compound means you are changing the entire compound. Okay? We are supposed to change the quantity, not the name, not the element. It's like this, children, I tell you. In olden days, during Shakespeare's time, they used to have actors, but the acting was done only by males. Even the female parts were acted by males. So what do they do when the male had to act like a female? Do you think they took him to the hospital and got himself operated? Did they touch him? No. But externally, they put hair and they put long clothes and they put rouge and lipstick and whatever. And he was only opening his mouth. The female voice was at the back of the stage. Okay? And he acted like a female. Was he changed like a female? Was he taken to the hospital, given a sex operation? Then after the role was over, again given another operation and made a man again? No. Internally, he was not touched. Do not touch internally. You can touch and change externally. Take out the wig, take out the long frock, take out everything. All right, the rouge and the lipstick and everything, and he is the same. So you can change externally in front of the compound. Do not touch inside the compound. You are interfering with the compound. Follow? Like the actors in Shakespeare's theatres. Have you understood? Is this clear? Now read. And how many of you do not know how to balance an equation? Raise your hands. All of you know how to balance an equation? Pakka. Do not say, Miss, I lost my mark because I do not know how to balance the equation. Are you sure you can balance the equation, this girl? Don't be frightened. Do you really know or you don't know? Okay. You may know how to balance the equation, but if you do not practice, you are going to lose your chances and you will lose your efficiency. So therefore, practice. All the equations in the book are to be written down up to what I have taught you. I have taught you right up to chemical equation and balancing the equation. All questions from page 1 of the chapter until here, you are going to do for homework all the questions at the back of the chapter. All the questions, yes, all the questions. Which part of my sentence you didn't understand? Which part of my sentence you didn't understand? All the questions in text question at the back of the chapter also, up to balancing of a chemical equation. Is this clear? So that next time when we come, I will start with, what will I start with? I shall start with I will start with relative atomic or mass ratio. I'll start with calculations. I will start with calculation. The chapter is going to get more and more tough and will be tougher still if you are not learning the previous part. Learn the previous part. I'm going to ask you oral questions. Okay? Oral questions I will ask you and I will want your books for correction. All your work up to balancing of a chemical equation. Is this clear? Don't say, Miss, I went out, Miss, I felt sick, Miss, I died and I rose from the dead. Those type of excuses, I don't want. What?
So is the partial equation method?
No, it's omitted. Please do not do it. You do it directly by the trial and error method which I have taught you. Is this clear? No excuses. And then don't stay at home because the homework is not done, you will stay absent. You will miss out a lot of explanation. You are at a loss. Followed? Is this clear? Good. 1 full week you have to complete all this. Every day you do small portions. Okay? You heard? Kada, you heard? Ah, good. Take your book. What are you looking at? Huh? Aram se Simran there. Planning to go again to the toilet? Huh? When we have English, you bring your treasure chest, okay? We start with work of artifice, okay? Language, yeah, but one lecture we do language, one lecture we do prose, then poetry, then Julius Caesar drama. What happened?
Could you repeat?
I didn't hear you.
Could you repeat what you said?
Bring all your textbooks for English. All your books you bring. Treasure trove, treasure chest, as well as your Julius Caesar. Treasure chest is so thin. Julius Caesar you bring. Language, total English you have, no?
3 books for Julius
Huh?
Caesar. There are 2, 3 books.
Only 2 books.
Only one book for Julius Caesar. Which one?
One is what?
Workbook you don't bring. Bring only the textbook, the main text. That
The black one.
black one.
Book. Physics of Julius.
There are various publishers. It's up to you, whatever your school is using.
I would have mentioned family.
From Africa. What she said?
Because it's black. So
How many of you are there for English? All of you? All of you are not for English?
It's also my double.
English? You're for English? You're for English, not for English? Huh? You are
Demo class.
you are a demo? Two okay, fine. You are the for English? You are a for English? You are a for English? Oh, Jesus Christ. Are you going to do English alone?
Yes.
Do you think you can do it alone?
Yes.
Who's calling you? The devil? Huh? The devil is calling you?
The washing is calling.
What he said?
Washing is calling.
Please, you come home. I'll set you right, okay? I'll set you right. Come, I think I'm going to pick up the books and sit quietly. Take a break. Pack up the books. It's time for you to go home. Pack up. What happened? How are you going home, Ian? How are you going home? Cycle. Opposite my house.
Where is it?
Where is my house? Sector 6. Who stays in Sector 6, Vashi? No, all of you are outside, from outside, Vashi. No, it's Sector 17. You? 29. Come. Okay, children, bye. Good night. You don't want to go home or what? Huh? Another lecture you want? Go run. I would have run home.
Oh my God.